and forces. Imagine that you are in a car that turns a fast corner. If you are sitting in the car, and the car turns, you feel as if you are being pushed to the outer door. But in fact, the car is turning, but because of inertia, you are staying in a straight line. So the car is actually pushing against you. It's a good place to be thinking about your frames of reference and how considering your system helps you isolate your forces. So the force on your body is the centripetal force. The acceleration, because forces are always related to accelerations in mass, is the centripetal acceleration. And the velocity, the linear velocity, is something that we're going to measure in meters per second. The centripetal acceleration will measure in meters per second squared. And the centripetal force we will measure in newtons. All right. A big opportunity for a misconception. A centripetal force is a real force, and it's a force that makes the body follow a curved path. So when you are in the car with your inertia, when the car turns, the side of the car will push you into a circular motion. Do not confuse it What is a centrifugal force?
Here's the definition of centrifugal force. An apparent force that acts outward on a body moving around a center, arising from the body's inertia.
So a centrifugal force is not a force at all. It is what you feel, almost consider it like a support force. It's what you feel when inertia is pressing you against the moving car door. So centrifugal force is not a real force. It's only apparent. If our direction of motion is this way, clockwise. Then we have an instantaneous linear velocity like that. Because the velocity is changing, you know that we have an acceleration. And it is centripetal. And because there's an acceleration, we know that we have a force that is centripetal. Again, if you are the person in the car who is making this radius, you are going to feel as if you're being pushed this way, but in fact the force is inward. It is always center seeking. Those of you who know Latin, centripetal is from the Latin root words for center seeking. The equations are the same as they always have been for forces. So the centripetal force is equal to the mass times the centripetal acceleration. The centripetal acceleration is equal to velocity squared over the radius in meters. And if I do a substitution, that means that my centripetal force is equal to mass times velocity squared divided by the radius. And the big thing that you need to remember here is that a centripetal force can come from many different sources. Some examples. A car in a parking lot doing donuts. You're able to do donuts actually just churning in a parking lot. Your centripetal force is equal to the force of friction. Your wheels are pushing off the pavement. You could have a weight on a string and be spinning it. In this case, your centripetal force is equal to the tension on the string. You could have the moon orbiting the Earth, and in that case your centripetal force is equal to the force of gravity. And this is the one that gets a little bit more interesting, and why we looked at ramps before. But if I have a car, a race car, on a banked track, so the car here was on a flat parking lot. If I have a car going around a track that is banked, then my centripetal force is going to be a normal force, which is the track pushing back against the tires. So that is your quick summary of circular motion and force.